Hello students, welcome back. So today's topic is conditional probability and it is very important topic. Probably your next topic is Bayes theorem, and in order to understand the Bayes theorem, this conditional probability is must to understand. So we'll see today one example, as well as we'll see the definition, how this definition is formed. So let's start the session. So what is conditional probability? The probability of happening an event A when another event B is known to have already occurred is called conditional probability. So we used to find the probability of an event. But here one condition is put up that another event B is already occurred. Means we are finding the probability of an event A under the condition that another event B is already occurred. So that we call the probability of that happening of an event A when the event B is already occurred is called conditional probability, and it is denoted by probability of A by B, and this A by B you can read as A given B, means probability of A given B. You can also say that probability of A given that B is occurred. So the formula is probability of A given B is equal to probability of A intersection B divided by probability of B. So let's understand how this formula works by using the Venn diagram. So you can see this is universal set, complete universal set, and suppose I'm saying that a certain event is happened, and I name this event as a B, and say its probability is probability of B. Now I have to find the probability of A, and we know that B is already occurred, whose probability is P of B. So this is conditional probability, means probability of A I am going to find when the probability of B is already happened. So there is a chance that A and B have certain common elements, and there is also a chance that A and B do not have any common elements, means if A and B are independent. So let's first consider that A and B have common elements. So if A and B have common elements, let's say that its probability is P of A intersection B. Okay, so we can see from this table that we have a B event whose probability is B, P of B, and probability of A is P of A. Probability of A intersection B, I said probability P of A intersection B, and then finally the probability of A given B is nothing but probability of A intersection B divided by probability of B. Means we have a sample space U, and when the event B is occurred, the sample space U, the sample space is reduced to the B. Then we have to find the probability of A. You know already B is occurred. Okay, so now suppose that if A and B are independent, it means A intersection B is phi. Then what will be the probability of A given B? Let's think. If A intersection B is phi, it means A and B are independent events. then what will be the probability of A given B? Simply, the probability of A given B is nothing but it will be probability of A itself. Okay, so let's solve some problems. The first problem is a family has two children and you came to know that one children is a boy. So what is the probability that second children is also boy? So what is your sample space, tell me? A family has two children. So what are the possible cases can be? Both children can be boy. Either first children is boy and second children is girl. Or this first children is girl, second is boy. Or both is girl. So you can say it's your universal set, or you can say it's a space, sample space. Now you came to know that one children is boy, or you can say one child is boy. So one child is boy. So what can be the space of this event? One child is boy. What can be the space of this event? It should be BB, BG and GB. Means first child is boy, second child is also boy. First child is boy, second child is girl, and first child is girl, second child is boy. Because you came to know that one child is a boy. So this is your event B, which is already occurred. Now the question is, what is the probability that second child is also boy? So what will be the space? What will be the sample space? What will be the event space for this event A? Suppose this event is A. So it should be BB. And why not? Because you came to know already one child is boy and you are asking for a probability of second children is also boy. So it should be BB. Correct. So now I have to find the probability of A when B is already occurred. Means probability of a second children is boy, or second child is boy when first child is already a boy. So simply you can see the intersection of A and B is simply A itself. So you can understand by this Venn diagram as well, as I explained the formula. So what you get from here, that event B, that the family has a boy, is this set BB, BG and GB. And asking for an event A, that the family has two boys, obviously the second child is boy and already first child is boy. So the set A is BB. So according to your formula, probability of A given B is probability of A intersection B divided by probability of B. So probability of A intersection B, So how many elements are in the probability of A intersection B? That is PB. That is only one element. And total number of cases are 4. So probability of A intersection B is nothing but 1 by 4. And probability of B means B has 3 elements. So probability of B is number of favorable cases are 3 and total number of cases are 4. So probability of B is 3 by 4. So you just substitute these two values and you finally found probability of A given B is 1 by 3.